Hello, this is the CUDAN Open Lab seminar on October 27, 2025. And today it's our greatest pleasure to have Melvin Wevers from the University of Amsterdam, who will speak about the architecture of information, how computational methods reveal historical structure. Melvin is an assistant professor in computational history, which is still a rare species that should exist more often. Melvin, the stage is yours.
Yes, thank you, Max. Yeah, so actually what I want to do today is basically discuss what I see computational history is about in a way. I don't want to do too much agenda setting, but there are some things that I've been thinking of for quite some time, and I want to use this talk to kind of flesh out some of these arguments. And I also want to do this using a couple of empirical studies that I've done in the past. And by using these empirical studies, I want to make a larger argument about computational history. And the claim that I want to make is that we shouldn't see computational history as only about scale, as in processing more structures, more sources. I mean, digitizing more sources, having more sources, but also use it to reveal structures at the scales in which they exist, and at scales at which traditional methods cannot operate. I think structure is a concept that has a long history in history, and it is a very important concept as it helps us think about where power operates, where meaning emerges, and where possibilities are also being constrained. And I want to do this by first establishing some theory, some theoretical framework, and then use the three studies to show how I've tried to incorporate some of this thinking in actual studies, and finally reflect a little bit about what this would mean for historical research. So let me start off with three challenges. I think in doing history, historians face at least probably a lot more three persistent epistemological challenges. And I think traditional methods kind of struggle with how to address this. The first one is causation. Often in historical narratives, we see these references, these nods to causal relationships. Did A cause B or the reverse? But establishing causality, but especially also the direction of causality, often in science requires also comparing with counterfactual alternatives. But this is quite difficult in history. We cannot just rerun history. We just have one history, and that's basically what we have to work with, or one historical archive that we have to work with. And that makes it quite difficult to actually do causal inference in historical research. There are some methods that I think can help to address this issue, and I will talk a bit more about this in a second. The second one is scale. Historical archives contain millions of documents, and as we all know, traditional methods often examine individual texts or a couple of texts. But this mostly reveals what I like to call the trees, but not the architecture of the forest that we're trying to understand. And phenomena in history and in culture are often emergent. They don't exist at the individual document level, but they sort of become apparent at an aggregate scale. But how do we analyze this? These phenomena that don't exist, that do exist beyond the individual document. And the third one is related to this. That's the notion of complexity. And a common response that I often find when presenting historians with quantitative work is that they say, yeah, but you need to take into account the context. Every case is unique. History is very complicated. It's a complex story. And in a way, this sounds like a very sophisticated rhetorical device, but often I find it ends conversation. And I do think we need more systematic ways to explain what has happened in history while still being sensitive to some contextual specificity. And what I believe is that we can use computational methods to enable some form of structural analysis that addresses these three challenges. Maybe not fully, but I try to see how far I can get with addressing them. So that also brings me to a notion that I often see in the field of digital humanities, I think, and digital history, is this notion of patterns that people talk about, finding patterns in big amounts of data. I think patterns are very important to reveal regularities in data, frequencies, and trends in these frequencies. They're quite descriptive in showing basically what happened. But I do think that patterns miss three critical aspects that are important when we want to understand what has happened in history and why it has happened. The first is mechanisms. Um, by looking at patterns, we cannot really see what are the processes that generate outcomes through aggregation of information or by feedback loops. The second is constraints. Patterns basically show what was possible or maybe what has not happened, but it doesn't really reveal how difficult it was that something happened or how costly it was or exactly how contingent. Historians often say, well, things are contingent, but can we find a way to say something about this contingency? And exposing the forces that basically constrain what could have happened or what happened in history. And then the latter, causation, I briefly touched upon this on the previous slide. Patterns can tell us, they cannot tell us why certain things emerge rather than others. So in a sense, the pattern is not the explanation. It tells us what needs explanation, but it doesn't do the explanation. And related to this, there's also, in addition to patterns, people often refer to outliers. In history, people often privilege exceptional cases, the maverick intellectual, the iconoclastic speech, the dramatic policy break. And these make for very compelling stories, but they can also obscure fundamental patterns in the data. And I think outliers become meaningful in relation to the structure that they transgress. So in a sense, the outlier depends on the norm, the historical norm at a certain time. And I think computational methods can reveal sort of the structural backdrop against which individual agency or outliers become intelligible. And then lastly, a concept that I will be referring to and then hopefully put a lot of emphasis today is this notion of structure. I believe that structure can reveal what patterns alone cannot reveal. In a way, they can reveal a relational architecture in data that shapes regularities. Um, not just what outcomes appear, so not just the patterns, but also how components within this relational architecture can constrain and enable each other. It gives us sort of a window of probabilities on possibilities. Not just what was easy or impossible, what was difficult, costly, contingent. Um, and it can also reveal emergence, so macro properties that only appear at certain scales, at aggregate scales, and that cannot be reduced back to individual cases. So the goal here is then to infer structure from patterns and then use that structural understanding to perhaps explain other patterns. That's sort of a back and forth between these concepts. And I think in a way, what we often see in digital history or digital humanities work is a strong emphasis on pattern finding. Often also without a lot of theory. We've seen this in sort of the big data discussions, let's say 20 years ago, that patterns will just emerge out of the data. I think by putting more emphasis on structure and integrating this with theory, we can maybe set a step to trying to explain what was actually going on. This is all not completely new, of course, what I'm saying. In some other fields, people have done a lot of work on this topic. And I find that very inspiring to also look at other disciplines. And I think one theoretical point that we can take from complexity science is that structure is scale dependent. In physics, people have said that physical systems behave differently at different scales. What looks like chaos at one level becomes a pattern at another level. Temperature is a very famous example. It doesn't exist in a single molecule. It emerges from ensembles, molecular ensembles. And I believe that in history, historical structure works in a similar way. For example, if we look at network structures in history, um, the network modularity, so clusters within networks, they don't exist in individual nodes. They emerge from aggregated relationships. If we look at semantic bias, it doesn't exist in individual words alone. It emerges when we map context and see systematic patterns in how words are distributed in historical data sets. And these phenomena only exist at specific analytical scales. And the the challenge here is to determine at what scale we actually want to be when trying to understand the phenomenon that we're researching in history. And I think this is also where computational methods come in. They're not just convenient, they're not just machines to be able to digitize a lot of material, but they also enable us to do more systematic multi-scale analysis of these phenomena, letting us zoom in and out to find where structures become visible and where emergent properties appear. And then there's the notion of causation as a theoretical background, and all these things come back when I move to the empirical studies and then get a bit more grounding. But one thing that I struggle with often when thinking about how to do history with computation is how do we establish causation when we don't have counterfactuals? Of course, there could be some form of speculative counterfactuals, but we cannot really observe what would have happened if X were different in history. And one potential solution here could be simulation models, like agent-based modeling or other computational simulations. That might be a way to test counterfactuals or isolate variables in ways that just observing what is recorded in history does not allow. But I do believe there's also another approach available that we've seen in the social sciences called structural causation, and where traditional difference-making causation, as they call it, asks the question, what happens when we change variable x? Structural causation asks a slightly different question, and that is how does x's position in a configuration generate or constrain y? So what is sort of this systematic, the architecture behind the network that makes x lead possibly to y? And the central concept herein is position, and the position itself is basically a lens or a hint of a form of causality in a network. And I believe there are three types in which this positionality can shed light on causation as part of a relational configuration. There is the temporal positioning, where something sits in a sequence, creates causal dependencies. What becomes before something shapes what becomes after something. An event's timing determines its impact, for example. So this is a way in which structural causation is determined by temporal ordering. There's also the relational position, how something is embedded in a network could determine causal pathways. Being in one cluster in a network could constrain connections to other nodes in a network. So network location shapes what can influence what, basically. So that is sort of the relational configuration. And then there's also the hierarchical positioning, and where something sits in an organizational structure could also constrain the visibility of the thing that has happened. And in that sense, also impose some sort of causal effect on that visibility. So, for example, what is prominent in an organization might get a lot of attention, and what is buried becomes invisible. This is also quite relevant when studying historical archives. And that is more like structural causation that is embedded in the architecture or organizational architecture. In all three cases, this causal mechanism isn't very clearly one entity acting upon another entity. It's more about position in a structure, again, generating constraints and affordances. I hope through some examples I can try and make this a bit clearer. But before showing you the studies, I think there are some requirements or guidelines that help us to do this type of structural analysis with historical data. I think one important requirement is that we should try and extract and preserve structure that is already in the data. For a long time, we just put data through digitization machines, stored a lot of words, and could do sort of a bag of words approach, and then something would appear. This works in many cases, I think, but there is also a lot of structure already in the data, and that there was often a trade-off in how much of the structure do we retain and do we throw away. I think now with recent developments in large language models, especially visual large language models, I think preserving and detecting structure that is already in the data um, is made much easier. But these are inherent structures in the data. There's also the emergent structure in the data. So structures that only become visible at certain scales, as I mentioned before. You probably all heard about topic modeling. That is a way in which you can sort of get these structures out of the data that the authors didn't explicitly put in, so more of like latent structures. Co-occurrence networks is something like that as well, but also communities in networks. And I think when doing a structural analysis of history, we have to preserve both what's already there and try and find ways to make visible what emerges at scale. The second requirement is we need appropriate metrics. And there's many metrics that are available in fields that are not the humanities necessarily, but that resonate with concepts that we have in the humanities. And I think these metrics are necessary because they allow us to capture these relational properties that I mentioned before. So they're not just counting things, they also express relationality in the data. So in network metrics, modularity, density, centrality are common ones. But there's also, when working with time series metrics like Granger causality, entropy, and then especially, I will talk about this in a bit more detail in a sec, jump entropy, to look at entropy within time series. But if we work with embedding models, distributional distance for semantic positioning is also a metric like that. And there's many metrics out there. And I think having a theoretical starting point and a clear research question helps you to find a metric that helps in shedding light on the data. Yeah, then the issue of working at appropriate scales. This is a very tricky thing that I think requires a lot of practice, going back and forth with the data, um, because the sources that we often work with in history and the structures that are within these sources are often not non-independent. So there is a lot of dependence between all these sources. So, for example, if you take parliamentary sources, speeches do not exist in a vacuum. They relate to other speeches. These debates, they cascade across institutions. People are part of certain parties. So there's sort of a nested structure within the data. And within that nested structure, it depends on where you are in terms of scale, what you can get out of the data. Statistically, I think people have done a lot of great work in terms of multi-level modeling to offer a way forward, where you can model on multiple levels simultaneously and look at cross-level interactions within the data. But I think the key insight that I got from working with these multi-level modeling ways is that we need to think of a systematic multi-scale analysis to find where structure again becomes visible, and also understand how structures at different scales interact. So a lot of theory, a lot of concepts, but let's turn to some studies. I wanted to first do 4 studies, but in the end I decided to do 3 in terms of time. Uh, these are all studies that I've done together with other people over the years, and I think they all kind of tap into these things that I discussed previously. The first one that I want to start with is a paper called Event Flow, and the research question driving this paper is how do events, historical events, disrupt and also shape the temporal flow of the news? For a long time, historians um, tried to conceptualize what an event was, maybe listed to a particular date or a particular period. I reversed it in this paper and tried to look at, is there a bottom-up way in which we can understand events? And events in such a way as seeing them as impacting the flow of information in newspapers. And impacting them in a certain way. So is there a certain shape to how a event in the world impacted the informational flow in newspapers? So what I've done for this paper is I took 58 major events between 1950 and 1995 and used information theory to analyze what happened in the front pages of newspapers around the dates around this event, and try to track what the impact was on the information content on these papers. Um, and well, fast forward to the key finding. I think what I could find is by clustering these shapes of events, I could find 5 distinct event types, event flows, I've called them. So basically archetypical patterns of impact. So very structural elements of how the news worked. So what we could see is that some events show a gradual anticipation. So newspapers slowly started to focus on this certain event and then slowly started to release this and started talking about other things. The moon landing was one of these events. But there's also events that have a very sudden impact, like earthquakes. You cannot really predict them. So they just happen and then the newspapers zoom in on this topic, discuss it. And then depending also on how severe it was, there might be persistent attention or it might just quickly disappear again. But there were also events that just didn't cause a lot of impact in the news. It was basically quite noisy in the background. Um, and here, this is a way in which I believe that this is um, a, a, a way in which these temporal architectures shape information flow. Let's see. Yeah, and you can only see this structure at scale. So by looking at individual articles on a certain date, you don't see this sort of impact in how the flow of information in the newspaper starts to focus on a certain event and then release again. But you have to do this on an aggregated temporal scale within a newspaper, but also across newspapers. And I've done this by relying on 2 different metrics. The first one we call jump entropy, which is basically a adaptation of Jensen-Shannon divergence, where we take the information content of a certain day in the newspaper or a certain set of days and compare it to dates 2 days in the future, 3 days in the future, 4 days in the future, and we take these jumps and compare it. And basically, if 2 days are the same as the 2 following days, then the entropy is very low. If it's the same 2 days and 10 days in the future, if it's still low, the entropy stays, or it's still the same, the entropy stays low. And by doing this, you get these graphs that you can now see on the screen, where the middle of the graph is sort of the central point of the event. And you can see sort of a run up to the event where the entropy goes down. People start talking about the same thing, and then there's a release. This is a very typical archetype of this, but there's many others. And we've done this with Jensen-Shannon divergence. And here also it was important to determine like at what scale could we find these patterns in the best way. And that was sort of the optimization of at what scale did this structure basically emerge. And the second thing we use is a technique called dynamic time warping. And we use this to compare the time signatures, the event flows across newspapers. So you see this bold red line, which is basically the aggregate of all the event flows. The other colors are different newspapers in the data set. And to find a way to sort of have an average of all these flows, even though some might have a little bit of a spikier way than the others, we use dynamic time warping, which allowed us to even with slightly different temporal rhythms, still find the average way in which this worked. And then we could use this also to do a clustering across all kinds of events throughout the newspapers. And this is sort of a temporal structure that is made visible through aggregation. So what does this show? What does this structural approach of history through this method show? Well, first we found that events have distinctive temporal signatures, and these signatures we could also use to try and understand events, but we could also use it as sort of a querying mechanism. So if we have a certain type of event, we could also use that to go through the entire time series and find spots in time that were very similar. And this pointed to events in the newspaper that when I started with my 58 major events that I didn't list, even though back in the days they made a huge impact on the newspaper. Max, go ahead.
Yeah, a brief question. In these plots, the wiggle that is sort of like on shorter order, that's weeks, right?
The wiggle? Which wiggle you mean?
So if you look at these plots, there is sort of like the general pattern that you cluster for, and then there is something that is sort of periodic and repetitive.
Yeah, in figure 7, it seems that the fluctuations are not completely irregular, but they have sort of periodic pattern.
Yes, indeed. So these are days, I mean, not weeks.
Ah, okay.
Well,
So you go 28 days before the actual event and 28 days after the actual event. And the here again, the bold line is the dynamic time warping, averaging, and all the lines in the back are from the different newspapers that we sourced.
Super, thank you.
Yep. So basically we could use these things also to find events that we didn't sort of canonize in the end. So it's also a search mechanism. And I think this is important also for a larger point that I wanted to make with this paper is that even though there might be a very strong flow disruption in the past, this did not always lead to something that is embedded in historical memory, and the other way around. There were events with massive temporal disruption that are now forgotten, and other events that we now remember vividly when looking at the newspaper content, they didn't make a huge impact. And I think this also shows that canonization also works in more complicated ways than just having an impact. And I think that has something for future work that I now only looked at front pages, but there might also be a way in which the information moves to other pages in the newspaper, and that there is maybe a feedback mechanism in these other pages. Let's see. So in a way, this to me is sort of an example of how temporal position also points to some sort of causal mechanism that I need to still untangle a bit further. Is and raises a question basically as when and how an event disrupts information, how this then gets into public consciousness. So for me, this was a first step in getting a grasp into this, and I think there's future work in which I want to dive a bit deeper into this. So the second study is also based strongly on time series analysis, and this moves from events to commercial discourse to advertising discourse. And builds on also this notion of temporal position as structural causation, but now on a larger time scale, entire century. And one research question that you often see in studies on advertising is basically a question of causal direction. Do advertisements shape public discourse, so how people talk about stuff, or do they reflect it? So is there a directional causality between the language in advertising and the more general editorial content in newspapers. Some people argue that advertisers introduce all kinds of new terms and which led to new desires and new ways of thinking about products, whereas others say advertising simply mirrored what was already there in the world. So what we could do is look at language, and then basically language in advertisements and language in articles, but that would only lead to, well, not only, but could lead to mostly leading to correlation. Are the same words being used in one source and in the other source? But the question that we raised in this paper is, how can we actually say something about sort of the temporal structure here and also the causal structure here? And we did this by looking at a list of words and the usage of these words in advertisements and in articles, again in Dutch newspapers. And we used Granger causality tests to examine whether ads predicted the subsequent usage in articles or vice versa. And the second metric that we used is something called adaptive fractal analysis, to understand whether the time series showed some sort of temporal persistence. So is there a repetitive structure in the way people talk about stuff, or is it a very bursty behavior? And the thing that we found is that there is a fundamental difference in temporal behavior between ads and articles, where we find that articles show very persistent trends with a long memory structure, whereas advertisements are very irregular with short bursts, with fast decay, which we hypothesize mirrors how advertisers introduce terms that then might gain traction or might not. We also found that the causality pattern wasn't as straightforward as we hoped, where it was either ads influencing articles or articles influencing ads, but that it depended very much on product categories. So some categories, like cinema and film, showed a very clear directionality from ads to articles. So the ad is sort of pushing language that is then picked up by the editorial content. Whereas things like vegetables and groceries had a very seasonal pattern, which of course makes sense because some vegetables grow in certain seasons, especially in the beginning of the century. This was very important in what was available. So in a way, these two methods showed these temporal relationships. Let's see if I can say a bit more about that. I think that's, yeah. So one short thing about the adaptive fractal analysis, basically you get, when you run a time series through the adaptive fractal analysis, you get a certain number, a Hurst exponent, which quantifies this persistence or burst dynamics in a time series. So if the Hurst exponent is, let's see if I say it correctly, if it's below 1, it indicates sort of more of a long memory structure, and if it's above 1, you have a more of a spiky behavior. So this is a very simple metric that you can use to understand very complicated time series, rather than just looking at them and saying, oh, it goes up or it goes down. I think that is also something that I see very often when people work with trends and time series, is that they just eyeball the figures, whereas there are many useful metrics that people can use to further understand these. So again, taking one step back, what do I believe this more structural approach to historical data reveals? I think it says something about directionality using this metric. You can say something about temporal structures that are different in a systematic ways. Here we found that for some products, we clearly saw that advertising has a sort of an agenda setting power it introduces novel terms that are then picked up in editorial content and also remain quite persistent. And again, the scale argument, you cannot do this by just looking at individual articles. You need to do this on a quite long range to get reliable information that you can then use. And this is impossible to do by just eyeballing a couple of articles. So the last study that I want to talk about today is a more recent study that I did together with my PhD student Ruben Ros. And in this paper, we looked at parliamentary data, so not newspaper data. This is data that has both textual content, but also a lot of structural information. Who was speaking, when was the person speaking, what party did that person belong to, etc. And the question driving this paper had to do with the notion of specialization. So in political theory, there's a lot of discussion about this process of specialization in politics, where people say if we have more specialists, political debate becomes more efficient, more analytical, and we want to have experts on economics, foreign policy, healthcare. Whereas other people say that this harms democratic pluralism. Basically saying if only specialists can credibly speak about certain topics, where is the broad deliberation where people from many different backgrounds, as a broader representation of society, discuss topics. But people have talked about this notion of specialization quite a lot in political theory. And the question that we asked ourselves was, can we quantify this process, this possible process of specialization? And also, to what extent did this constrain what people could talk about? So could we find specialization, and can we find whether this also limits people in the freedom that they have to discuss certain topics? Because if people become very specialized, they might only talk about the thing they're really specialized in. And this is also something that people call epistemic capture. So people capture a certain topic and define that we are the only ones that can talk about this topic and no one else. So we thought about how can we actually do this and also look at this not so much as a process of censorship where people explicitly say, okay, I talk about this, but you cannot talk about this. But to what extent is it part of the sort of network structure, the structure of the parliament and the way people debate things? And to do this, we analyzed 50 years of Dutch parliamentary speeches. And we used topic modeling to reduce the dimensionality of the speeches. And then we used, we looked at which topics co-occurred with each other and created this into a network structure. And the next slide makes it a bit clearer. So basically, we created these linkage structures, which say, if you discuss topic A, there's also a high probability that you will discuss topic B, or maybe a high probability that you will discuss topic C. So using point-wise mutual information, we basically made a network structure that linked topics to each other. And we did this in 6-month windows. So we had networks for every single 6-month period. And then we also made clusters, finding communities within these linkage networks. And we tracked the evolution of these clusters over time. So how they actually formed as debate progressed over time. And this actually revealed an emergent structure in the network. So communities that were not designated by an individual member of parliament, but they happened because people started talking about certain things and only talking about these other things within a certain debate in parliament. And what we then did is we looked at this at multiple levels. You often hear about this oscillation between close and distant reading, where people look at the individual sources and look at some aggregate metric. In this paper, we try to think about, in the metrics themselves, can we also think of different levels at which different structures might emerge, rather than just looking at one aggregate structure. So what we've done is use different network metrics and think about at what level should we use them, and what does it actually tell us about this possible process of specialization that we were interested in. So we used modularity, so the degree of community structure in the network, and density at a high level. And on the graph on the left, we can see basically how these two developed over time. So the modularity goes up between 1950 and 1975, whereas density, so the overall connectivity between topics across the entire network goes down. And this for us was already an indication that there was some process of specialization going on, as debates split basically into isolated specialist domains. Things related to economy often appear together in a topic, whereas economy and foreign policy were not often discussed together. So there is a compartmentalization of parliamentary debate happening. And the graph on the right also shows how stable these structures are. As I said, we have these 6-month snapshots basically of these structures appearing. And we also looked at the normalized mutual information between these linkage networks. And basically in the graph on the right, we see sort of the stability between these communities increasing over time. Although we do see sharp declines, and these often correspond, or almost always correspond, with the formation of new governments. So normally in the Netherlands, we have a new government every 4 years. There's new elections. More recently, we have it almost every year because we cannot keep an election or a government in place for more than a year. But we can see that there are these political disruptions on a sort of smaller level that impact the steady trend. But then again, it quickly moves back again and goes up in this upward trend line. So there is a sort of a resilience in that process in the network. So as I said, we looked at different levels. There's also the meso level, so not the macro but the meso level, where we were interested in the specific topics. So in the previous graph, we looked at the entire network structure and how is it actually stabilizing. But we also looked at specific topics and how similar a topic's neighborhood is to the neighborhood 6 months in the future, 12 months in the future, etc. So very high values, and here we use an overlap ratio, which is sort of an adaptation of what people call Jacquard distance. Where high values mean very stable neighborhoods. The same topics keep appearing together, and low values mean disruption. Or topics are suddenly occurring with very different topics than before. And here again, we see the cabinet changes impacting it, sharp drops, where local neighborhoods destabilize when political leadership changes. But again, there's a gradual restabilization over time. But the funny thing here is that we could also zoom into particular domains in the political sphere. So we looked at topics such as inflation, international conflict, but also broadcasters. And this is what I mean with the meso level. So we could also, within specific topics, look at what is happening with this stability over time. Is it always very low, as is the case with broadcasters? Or with inflation, we can see that there's more of a gradual development, where especially in the 70s, a lot of economic crisis, the oil crisis, it goes slowly up, whereas international conflict seems to be perturbed much more by external events. So there's a more of a random pattern in the data, so to say. Yeah, let's see. So for me, this is very much an example of using different metrics at different scales to look at sort of structural dynamics in a historical process. At the macro level, we found that there is sort of a progressive compartmentalization. So specialization is on the rise. But again, it also evens out in the late 70s. And Ruben, who knows much more about the whole political background here, hypothesizes that this has to do also with sort of a neoliberal framing that that blurred boundaries in what people could talk about. So everything is sort of connected to the economy during neoliberalization. At the meso level, we see cabinet changes that sort of have epistemic reset switches. Every government change disrupts neighborhoods, and these structures do restabilize again over time. And at the smaller level, we can see that individual topics follow different paths. We've also done analysis that I left out here, where we look at what role did individuals actually play in stabilizing these communities. Were there certain people, certain parties to build on this process? And I think by scaling on these different levels, you get an insight in the complex behavior here, rather than just saying, "Oh, it's complicated, we cannot say anything about it." This sort of opens up the box of all the processes and the intricate dimensions that that take place here. Here again, it's not very hard causation that we're talking about, but this is one of these examples of relational causation, relational position in structural causation. I mean, we shouldn't look at networks as sort of cause and effect that you can see when you're playing a game of snooker, where a ball hits another ball and there's an immediate cause and effect. But it does shed light on a certain architecture within the network structure that does give rise to certain things, allows certain things to happen, but also constrains other things to happen. Modularity is a way of looking at this, but also density. And if there's a very low between community density and a very high within community density, it becomes much harder to make arguments across domains. And in a way, this also hints at this notion of power that is captured in this architecture. There doesn't seem to be a very clear central authority that has said, we are going to specialize, but it is sort of something that happened in a sort of emergent, distributed manner. And by just looking at the content of speeches and looking for linguistic hints of specialization, I think you don't find this sort of architectural power in the network that is also an element of specialization. So a structural way of looking at specialization. I see that I have 10 minutes left. I have some concluding remarks that I want to make. In doing or trying to do the computational history that I'm doing, I often get some common evasions that people in history present myself with. First is the what I named the complexity dodge. I briefly mentioned this before, that by saying that history is complicated, every case is unique, context matters, you cannot reduce this to numbers. I do not really see that this is a very intellectually productive way of moving forwards. Otherwise, history just becomes things happening after each other. And I think, in a way, I think we need some form of abstraction, a disciplined way of abstraction, and I believe that engaging with history in through more structural analysis provides this, by specifying exactly what we measure, at what scales we measure, what methods we use. We make our analytical choices explicit and defensible. We can have a debate about it, but at least we know what we're actually debating. And I think this makes our approach specified. It makes it replicable. It makes it empirically grounded. It's derived from actual data. And we try to explain how things work, not just describe what happens. And I think this is still something that in history we can learn from a lot of the other sciences, but I think it's important to set steps here to move towards real explanation of historical phenomena. The second evasion is the outlier fetish. I think too often we privilege exceptions, resistance narratives, and boundary crossing as more significant than structures. In a way, this does reflect survivorship bias in historical scholarship. So, very briefly, survivorship bias is the systematic error where we study only what has survived, succeeded, or became visible, and ignoring the larger population that remained invisible or didn't succeed. And I think when we only focus on exceptional individuals, or movements that succeeded or ideas that gained prominence, while ignoring structural constraints that made made other things not appear. I think this is a very dangerous route and leads to a clear form of bias. Archivists sometimes also call this historical or archival shouting, by only looking at the very loud voices in the documents that we have. And I think by privileging outliers, we also create false impressions that boundary crossing was very common or easy even. If we cannot say how difficult it was by looking at the structural forces in an archive, it becomes a bit difficult to say how special the outlier actually was. And it also leads to selection on the outcome variable, on the dependent variable. So if you only choose cases based on the outcome you're trying to explain, you might lead to biased conclusions. So it's a bit like studying only lottery winners to understand economic mobility, basically. Only looking at the winners and then try to explain the entire system. I'm not saying that all historians do this, but I think by understanding the structure, you better understand the outliers. So in a way, we need to do both and go back and forth between the two of them. Some conclusions. So what I do think computational history should do and what it is not about, and this is very much my my own opinion. I think we talk too much about processing more sources faster, scale as mere convenience. I think it's not just about finding patterns in the data. I think we also need to start with theory that's driving how we want to explain these patterns. And it's also, and this is a very thing we often see, it's not about replacing close reading. I think this is a very false dichotomy, and it creates a lot of needless conflict. I think you need both to strengthen each other. But I do think that computational history is good at making structures visible at scales where it exists. And it also can help to reveal mechanisms that operate at different scales, but also in different ways. Causation is one of them, quantifying constraints and possibilities, and also trying to understand emergence. And I think the last thing that I will say about this, let's see. Yeah, so to get back to the title of my talk, the architecture of information, I think in a way by looking at the information that we have, the data that we have at a very structural way, gives us insight into power, the way it is organized, not just the way it is expressed in content, so in text. It gives us insights into meaning as it emerges from relational configurations, from distributional patterns, network positions. And it gives us insight into constraints, um, how difficult it is to do something, how probable it is that something happens. I think getting more numerical values attached to this, and also knowing something about the uncertainty that we have about some other things, um, really helps to understand what is underpinning this information structure in historical data. Yeah, so today I talked about temporal structures, so in the time series, and network structures, but I do think there's also, these are not all the ways I think structural information is captured in historical data. There's also institutional structure. For example, how have archives organized their knowledge? We can use computational means to look at this. There's also semantic structure, people using word embeddings to do that, or other types of embeddings. And some other work that I've done is more on the multimodal aspect. So how do visual and semantic dimensions, by linking images and text, how do they also allow us to convey information in the past? So what kind of constraints can we find there? So there's many more dimensions, I think, in which we can find this structure, but I think we should focus a bit more on getting the structure out of the data that we have. And why? Because it explains patterns, it contextualizes outliers, it enables the analysis of mechanisms and constraints and emergence. And I think this is not just quantification for quantification's sake. It's revealing architectures of information within which human actions actually occurred, that could shape probably how likely it was that certain things happened in the past. So my plea here is that we should foreground structures a bit more in history, and focus less on the outliers and maybe a bit less on just the pattern recognition. I hope this has sparked some questions, and I'm happy to take the questions and discuss this all a bit further with you. Thanks for your attention.
Thank you very much. Everybody's clapping, but you can't hear it because Zoom actually cuts out the claps.
It's noise.
As usual. Okay. Took us 5 years to find that out, actually. So yeah, I think there's a lot of questions. I certainly have some. Anybody else wants to start?
You start. I have loads of questions. It was super interesting, but maybe you can start and I'll pick up after that.
Okay. So yeah.
Do you want me to continue sharing the slides, Max? Is that helpful?
I think you can leave them on, and then like we can, maybe you want to sort of like shadowly move to the right slide in the background if you think this is making sense. So there's a whole bunch of things which are sort of like really, really cool and refreshing. And there's a bunch of other things which I found like quite interesting, which I would formulate differently. What I find very refreshing is this formulation of sort of like issues that we all encounter all the time, like the complexity dodge, as you called it. That people say, oh, history is complicated. It's different every time. It's ideographic, not nomothetic. You cannot just like put it in a huge pile, stuff like that. Which obviously you said is not a good productive way to move forward in history. But let me finish the sentence. But it's a really good way to kill funding proposals by Melvin Wevers, Max Schich, and other people who actually do this kind of stuff. So this is sort of something which I think can only be a call to the community, that we need sort of like a kind of, how should I say, an awareness that qualitative history that doesn't quantify is dominant still in evaluation panels, and therefore, this thing will kill a lot of proposals. And often you never hear this, right? Like you're just on the threshold. But I have said in so many panels and evaluation gremia where that was sort of like the killing factor, like the main factor. which is, I think, really crazy. And then, you know, what you say, outlier fetish, that is sort of something which I think raises an issue which I, on the one hand, agree with you, but then also do not agree with you. Like, your kind of thing is to say, okay, we actually want to explain, and you actually mentioned this word, a real explanation, which I found really, really interesting. So, and that has to do with this word causality. So the other killer argument, other than sort of like in history, everything is special and there is no complex emergence, the other killer argument is the approach is just descriptive. And if we would be really, really honest, there wouldn't be any astronomy if you could only publish the picture if you would actually sort of like have some causality. Like whatever comes out, James Webb Telescope, Hubble Telescope, or whatever, is first and foremost the labor of thousands of people who sort of like produce an image which is basically just descriptive, and you try to get rid of anything that's, you know, there is a sort of like bias that is caused in some way or another. And in the same way, a lot of archivists, historians, and whatever have been marginalized into sort of A, service jobs, B, less money, and D, not being mentioned as co-authors because everything they do is quote unquote just descriptive. Like, you know, PhD art historians that classify, I don't know, the Corpus Gernsheim 50% of their time while doing their PhD, but they actually don't get any publication out of it because, quote unquote, they just described 5,000 pictures. And so that is sort of something which I think we need to be a little bit more careful, particularly because there is sort of things which are sort of alternative. Like in archaeology, there is this guy, CUDAN, who wrote this book called Archaeological Constructs, which has been super influential for people who, you know, built knowledge graph in the 1990s. So it's a book of the 80s. And one of the interesting things, the central figure actually has several sort of pathways to explanation. And one of the interesting things is they all have generating mechanisms. They all have dynamics. But in many cases, if you're really honest, it would be super hard to actually sort of get to some kind of causality. And I think that's where sort of like the more problematic part of the discussion could be, like, for example, if you have to ask yourself, like, how cool is Granger causality really? Like, it's a really cool thing, but I think it's also a term that sort of like, do we pretend that we're in the same realm as like people who, you know, write causal models and evolutionary game theory and stuff like that? Or is it something where we say, yeah, okay, so we get some kind of directionality, but we actually need to be really careful because even if that's the only thing we look for, we miss all the other dynamics, which, frankly speaking, we don't have any causality whatsoever.
Yeah, so let's start with the last. People often also mention that Granger causality is sort of a pseudo causality, also that it is sort of is a nod towards a form of causality, and in a way it's a very simplistic causality as well. Even though you look at complicated time series, it relates to other things, and I think for me the interesting thing here is that sometimes in discussions with historians, I hear that they make causal assumptions based on their domain knowledge, on some sources that they've read, where I think we can use these models to test at least the assumptions that people made and how probable they were. And I think Granger causality might be one of these things, a simulation model that starts very simple, basically already can show how improbable it is that this on a very simple scale works, or maybe on a more complicated scale. How many of how many factors you need to actually explain this, and I think basically just questioning the causality in itself and trying to flesh it out, to me, is already a step forward in doing this kind of work. And I think even as far as I know, where for the more natural sciences, I think this is also very much an experimental condition where people go back and forth with these models and try to understand the causality and then change the theory to see if it taps back into the causal relationship. So just to give a very brief example, and then I get to your first point. I I I did some work on social mobility within the East India Company in the Netherlands. And I tried to make a very sophisticated multi-level model to explain like what are all the factors that impacted when someone could make a next step in their career. And I couldn't find a way to flesh this out. And it turned out that if I would cut up the entire period, the system basically, into two, a lot of the factors impacting what happened went in a completely different direction. So where it was positive before, it was negative in the other direction. And I didn't take this time as a grouping variable, so it would even out the directionalities. They would be sort of be opposing each other and didn't work. And once I cut up this period, I could find, okay, now my factors explain a lot of the things happening in this period, and they explain it in the other period, but they explain it in a totally different way. But that in itself already was giving me a hypothesis and talking to the historians who know much more about the East India Company, like what happened in this first period and in this other period. And then you could also cut it up in even more periods. But I think that is for me a very, well, I would say it's a productive way, but getting at like what could the causal pathways be here? Or sometimes even drawing it in like a graph and presenting it to the historian, making it without any computation, just on a piece of paper. Trying to reduce the complexity into that sometimes even helps, I think. And that ties into your first point, I think. There's a lot of resistance. I totally agree with you, which I also find strange because there is a lot of historical work on causality, on complexity, that has been around, let's say, since the 1930s at least. And even I've noticed this, and I don't want to be whine too much about this, but in proposals, if you even allude to these people that have done this work and use it as an argument against the arguments that people would make against doing quantification, people still say, no, you cannot do history like this. And that to me is like not productive. If people want to disagree, I'm totally fine with that, but then at least have a actual discussion of what we're doing and the explanations that we're giving. But yeah, I won't whine too much about the whole grant system, I think.
No, we shouldn't whine, but I think it's an important thing to sort of like raise because actually, I think it's an interesting sort of like persistent trend in the system of science and research. To not call the humanities a science is sort of something which has a really strong undercurrent. And it's almost the same as like, you know, some of the people I worked with, they worked on the polychromy of Greek and Roman sculptures, which is undeniable. If you use UV light and raking light and stuff like that, you actually can see they were all colored, and white was the exception. But every time you give a talk like this, it's now 2024, and the first talk like this was given in 1835 or whatever. Every single time people are shocked, and every single time they sort of like pretend it didn't happen. And I think that is sort of something which is rather similar here. And it has to do with the fact that we're trained out of it. Like, you know, that's like what I said, like computational history, it's a rare species because you need to study computation and you need to study history, and there is some places where this is possible, but then there is a lot of places where this also sort of like is complementary to how it's actually done. And obviously, people would like to have it in this walled garden, right? So you find a lot of curricula where this doesn't happen, basically.
Mm-hmm.
Mm-hmm. Mike.
Yeah. Basically, first of all, thank you so much. It was really, really, really interesting. You've resonated very much with what I've been thinking about on this topic, but I'm a physicist, so for me it is sort of a problem. Sounds quite a proper way of doing history. I have a number of questions concerning the sort of the concrete parts of the examples you discussed, but probably, well, in this round, maybe we still have time, so probably in this round, I just concentrate on some questions and remarks concerning your sort of methodological part. One thing which resonated very much with me, and maybe which is maybe sort of symmetrical to in a sense to what Max and you were just discussing. It seems that as you've shown, there's some pictures with these patterns emerging on different scales, etc. That indeed people from complexity science and from physics in particular might be useful in the field and can bring a lot. Although when they, unfortunately, very often when I see people trying doing something, they do sort of an opposite limit compared to your sort of outlier fetish thing. Namely, people try to describe everything in the same time and concentrate on very large scales and sort of without, well, with the limited knowledge of concrete history, try to do wide generalizations. Whereas interesting thing here is, of course, that each scale has its own structures. And the richness and complexity of history is in understanding that you cannot just do it as a collection of facts, but you also cannot do it as a sort of one overarching narrative, or I don't know, one overarching formula or set of formulas or whatever. And basically it resonates with other things in complexity science. Recently there is this, because I mean, for example, the pattern you shown with this sort of lamellar or whatever structure emerging from house as you go to larger scales. It is sort of history. It is sort of a story which develops just with one characteristic scale. If you look at small scales, there is a house, and if you look at larger scale, there is order. And there was a lot of like 30 years ago, there was a lot of argument in complexity science that there are sort of these scale-free patterns, and if you forget into the minor details, then you have this scale-free, and that is complexity. But actually, we do understand now that it is sort of a different sort of simple patterns, and real complexity emerges when you have basically you go from scale to scale, and you have a different story on each scale. That was one thing I wanted to say. Another is concerning causation. Basically, one thing which comes to mind is that what in economics they often do and gives, I think, Nobel Prize a couple of years ago, that sometimes it might be possible to have what is called natural experiments. Yes, that there are sort of different parts of the world which you can quantifiably say that they're up to some point to a certain extent similar, and then in one of them event happened and another it didn't happen, and might be possible, well, might be useful to understand causality. And another thing which Well, actually, you just said it in your example with this India company, and we found it too in our work on Soviet news with Mila and Max and Mark, who is also here, that to have a quantitative model, quantitative predictive model, even if it is very stupid and primitive, is very much useful. You immediately notice things and can quantify things which you don't understand. And yes, and one more aspect which probably, well, I mean, it was sort of underlying all the things which you were talking about, but probably worth explicitly mentioning that slicing data further and further, like separating the whole history of West India Company into slices, then into small slices, then at some point you get to the point that when there is just noise, or you can construct a very complicated model which predicts, which formally explains everything, but actually explains nothing because it is just overfitting. So there is a need for this sort of this sort of um, 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 actually quantitative understanding when to stop. And the third thing which I wanted to say about the sort of the theoretical framework concerning the outliers, well, also three things. One is basically we do understand that history is events are distributed in not normally and typically, and people are not all the same, and etc. So you always have long tails, and so you inevitably have outliers. But anyway, we found that outliers are very useful in rebuilding models. Yes, more or less probably as what you said in this last example. And one more, what I wanted to say at last. Yeah. Actually, it goes back to what I started with. I still remember, Soviet school system, and I was up to sort of 15 or 13 years old, trained in sort of very Marxist standard paradigm of explaining history, and we were taught at school that outliers are nothing, that you could not that it is not a proper history to study them, and that you always should concentrate on sort of big forces and true explanations, whatever it means, etc. So that is basically to say that you can make a fallacy in both directions, and the proper way of understanding is inevitably having both of them.
Yeah. So let's see. I think the first thing that resonates with me in all you said is that I think the what I'm no expert in complexity science. I do read it every now and then, and the thing that always strikes me is that in complexity theory, when you have like a large system and you try to understand the complexity and try to find transitions in the system at sort of a larger scale, I think one thing that doesn't really work when trying to for history is that there's a lot of forces outside of the thing you're studying, or because the data only gives you a very limited perspective, that could perturb how the system actually works, which is also interesting, I think. And I think rather than so the time dimension for me is you have complexity and there's scales in that complexity, but the time dimension adds another layer of complexity in a sense of and that's the notion of periodization, I think, that in history is often very important and people discuss. But I think you can also use this as thinking of, are there certain periods at certain levels in that complexity that you can try to untangle? And to me, it very often feels almost like peeling an onion. Are there sort of very large things that you can explain away? And then you end up with all these nitty little bits that sort of are the long tail effect. But I think very often we start with the long tail effect and focus very much on that. And I think by starting at trying to understand some of the structure, or where we don't understand the structure, is, and there are ways to do that. There's metrics to do this and methods to do this, makes the outlier to me also much more interesting. And I think in economy you see this, that people have done this, and I think in a lot of Marxist history people focus a lot on social structures and economic structures. But I think when we talk about culture, and I know that you guys in Tallinn have worked on this as well, there are theories from cultural evolution that and cognitive science that also give us things or models to try to find structural things in culture. And if peeling away those layers leaves us with sort of the noise in, I sometimes believe that is what makes culture also interesting. And nowadays there's a lot of talk about bias, of course, because AI models and bias, and historians, when working with archives, often also talk about it's not representative. There's a lot of bias in the archive. But where is that bias? Can we gauge what this bias is? Let's ask these questions. These are maybe simple questions, which might also explain why you won't get grants asking these sort of simple questions. But answering them is actually quite difficult. And maybe take a step back and try, well, peel away these layers of the onion and see where we get that then. So
I
see
think that is a really cool. That's a really cool sort of like point one should emphasize much more, right? So these simple sort of like, and like, pardon me, descriptions of what can come out. Like you showed these, and thank you very much for doing so. You showed these cellular automata, Wolfram style, right? So Wolfram's New Kind of Science is a book which, you know, I think is one of the three largest books I have for art historians. SML Excel by Rem Koolhaas is a tad larger. And, you know, it's full of these kind of pictures, and he can't explain. Of course, you can sort of in detail explain the generating mechanism, which is a particular sort of like rule 32 creates pink noise or whatever. But you know, if you look at a certain subsection of this, it doesn't help you. You cannot say, oh, this is rule that or rule that. And so that is, I think, one of the important things that we actually have to, in the literal sense of the word, explain, like put it on the table and actually look at all these different things. And where we can find causality is cool. Like, you know, somebody who finds some true causality in history gets a PNAS paper, science paper, a Nature paper, I don't know, or, you know, sort of like a Routledge book. I have no idea. But it's also important to sort of like show the full bandwidth of stuff that actually does exist. And so for me, the question boils down to one thing, which I wrote down where you were talking. So does a mechanism, like a generating mechanism, always need some kind of causality as a goal? Or can it also be that the generating mechanism, for example, leads to a non-deterministic result? And therefore, we see a non-deterministic pattern in history where we can say, oh, okay, so we can probably see the class of generating mechanism that actually leads to that outcome, but we cannot tie it down. Like in the same way that preferential attachment produces power laws, right? But a sum of 1,000 stretched exponentials, like, you know, sort of like 1,000 people having a different generating mechanism, may actually also result in the same power law. So you cannot say what it actually is. And so there is also some beauty in that, because that means there will be not just one book, but it will be minimum two or probably many to come up with different explanations. But we need to sort of like put it all on the table to actually at least know what we're talking about. And it seems to me a little bit like, while we have books with all Gothic ground plans, with all sort of like a catalog of all paintings in the Prado and stuff like that, it's sort of not allowed to, for example, do just, you know, a really stupid zoology of temporal patterns in history, for example. I mean, it doesn't really exist, right? Or do you think there is a sort of like, you know, do you dream of a sort of like thing that you would love to do when you don't have to talk about causality all the time, basically? That's my question.
I think for me, yeah, that's a good question. So I think let's start somewhere else, and then maybe I end up where what I would like to do. Is I get that people say stuff is complicated and there's a lot of things happening. But then for me, the work sort of starts, and I think even doing a very simple generative mechanism can lead to these very complicated things, and that can shed light on the thing you're studying. So I guess, and that doesn't have to be causal, but I think if that has a differentiating potential by showing that two different generative mechanisms or changing one variable has a huge impact on the outcome, that I guess already sparks a conversation that you can then have with the historian studying the thing. You could say, oh, the thing you thought wasn't that rare is actually quite rare, or the other way around. Or for example, often when I said we don't really have counterfactuals that we can use, well, one thing in temporal ordering, sometimes if you just randomize your data in terms of the time series that you have and then do the analysis that you've done, is a very simple way of finding out whether the temporal ordering helps actually finding some pattern that you're interested in. Is the pattern still there if it's randomized? Okay, then maybe it doesn't have anything to do with the time dimension. And I think basically problematizing a lot of these assumptions, I think, is actually very important in the work in the humanities. And I think a lot of the critical work that so I guess one of the things that in a larger debate is with the cultural turn in history and people reflecting on using these basically laws to describe how history worked. I think a lot of this criticism was actually quite valid, but it's also criticizing methods that we don't really use anymore, and we have also progressed in thinking about these systems. And we can actually use the things I think we're doing now in cultural analytics and computational humanities as also a critical tool to flesh out the complexity and the dynamics in these systems, rather than just reducing it back to basically a one-line formula, this is how the world works. I think that is not what people try to do. And I think even when I look at people working in literature where it's much more acceptable to use computational methods, it also breaks down genre, it breaks down canonization. So in that sense, it has a critical potential as well. It's not just reifying, well, structures from the past, I think. And so I guess that's sort of what I would like to do. And if that's a causal explanation, that is one way. But I think through contrast, finding difference, that is also a way of doing that. And basically, and I think having models to show, I think coming back to what Mike said, indeed, you can make very complicated statistical models that overfit, but there's also ways to then look at the quality of your models, how generalizable the model is. There's metrics to do that as well. So, and I think for history, it's the same discussion. Do we want a historical explanation that is basically overfitting to this one example, or do we want to have an explanation that can also have maybe some political power or some rhetorical power that is not overfitting in a way, but that, yeah, that requires a different way of thinking, I guess. And I think computational methods can help doing that as well.
Yeah, Mark Met has a question.
Yeah. Oh, thank you for the presentation so much. So I had a question that was pretty simple and straightforward, but regarding the larger topics that they discussed, maybe I will connect it through those actually. So the idea that to take the idea that you mentioned that it's too let's say history is maybe too complex to quantize it or something towards that. That it's actually, if you think of in terms of this discreteness or continuity, then it looks like maybe continuity is this complex thing that the human would describe, but no, like we all have our still experts or like historians have their own perspective, own memory and limitations based on which they can create the relations, and then you get to the this computational or like data-driven study of this history, and you would still run into limitations, but it's different ones. So therefore it provides still a new and enriching perspective, right? But the question itself actually was that connected to the, I think the oldest of these studies with the, of detecting events, that I guess the examples there seem, you mentioned also there's different types of events actually that you brought as an example but how would you deal with this more complicated types of events in there, that you have this shocks and aftershocks, or like event related to other event, that then like you can barely see the end of one when the other begins, and also that just the how to say the baseline changes and things like that. So that was the more specific question, maybe following the more general in the beginning.
Yeah, no, this is a very valid question, and I think that this sort of taps into what I was saying before in, let's see if I have the example on the top of my head. So I had this whole theory of how earthquakes produce a certain event signature, because you cannot really predict earthquakes, and then once they happen, people start talking about something else. But then I was using this to find moments in time in front pages, and I found that actually when two events occur at the same time, this caused difficulty in my model. So if there's like a I don't know, I'm not sure what it was again, sort of more of like a revolution that is taking a couple of days and there's a lot of commotion in the society, and then in some other country there's also an earthquake happening and they're both on the front page, then that sort of makes the front page a more complicated thing than just reporting on one newspaper story. And that was one of the modeling decisions that I made, where I took the entire front page and ran it through a topic modeling algorithm to reduce the sort of complexity of the front page into topics, and then use that as input to do the entropy. I think if you want to untangle the way that different events, so basically different articles, interact, you have to approach the concept of the thing you're studying, the front page, as articles, as a network, basically, I think, where the articles also relate to each other. There could also be 5 articles on one topic and then another one. And to make it even more sophisticated, if something happens in the world, then maybe it moves to page 3 the next day and it's still being discussed, and then maybe in another section, and then it moves back into the front page again. But that is also part of the dynamic. So if you really want to capture all these intricate dimensions, that is a model that you need to build, which is computationally more complicated. But then again, compute isn't too big of an issue now anymore, I think. But in a way, having this one model that I had now pointed me into things that I could explain even with this relatively simple model, but also cases where I couldn't. And so that is the next step if I were to continue with this this project. Try to explain these kind of things that you were just describing. And I think that is sort of the process. I think that is very fruitful to constantly use the computation, find the flaws in a model, and find models that explain better the phenomena that you're trying to understand. I hope that that answers your question.
Yeah, it does. Yeah, thank you.
Thank you very much. Okay. Yeah, I got a question which changes the topic a little, but we talk a lot about methods. And you have one, you studied one, the event flow thing, which you end up with one core result, which is that articles have a more sort of persistence patterns of trends, of rise and fall or whatever, while ads seemingly are more bursty. And so that's one measure, sort of like your Hurst exponent of like basically how regular the signal is.
Mm-hmm.
One of the interesting things is your data set is, I think, from, if I remember well, 1945 to 1994, right? Which is not the present, but actually the Monday before the, I think, 2020 election in the United States, we had a speaker in the Open Lab seminar who was Peter Dodds, who was talking about Trump turbulence, like how Trump induces new words every day into the Twitter stream and conversation, often saying opposite things on the same day, and see what sticks and then run with that. That seems a lot like what's going on with the ads. But obviously, this kind of strategy, in the same way as advertising, tries to go into a certain direction. And, Joseph Goebbels would say hypnosis and suggestion. So you suggest something, you don't actually cause something, but in the end, you end up with, in our case, xenophobia, homophobia, transphobia, misogyny, like the usual stuff that is sort of like rolling out all across the world. And to give you a little sizzle for my question, which will be, do you think that your methods or methods like that can be used to actually help in the current situation, to actually sort of like emphasize how the system is manipulated by very few people with a lot of money injecting sort of like, noise in the system, like, for example, with the ads in a bursty manner. Can we actually use these methods in real time now, particularly that Twitter is gone? And so here's my little framing of this. In spring 2015, I lived in Garland, Texas, which is sort of a place where the mayor had the goal that he can buy a suit in his lifetime in Garland because most people drove to Dallas. So there's nothing happening. There was a little school that had a sort of like ecumenical, people from all faiths meeting in a school. And as a reaction, an anti-Islamic sort of like congregation from, I think, DC, did a little meeting in this little school, 900 meters from my house, and there was a drive-by homegrown Al-Qaeda terrorist shooting at people who looked a lot like Proud Boys but were policemen which were out of service on the day. And because the shooting happened, people died. Because the shooting happened, it actually transpired that Geert Wilders was in the building. Okay. And so I obviously, like you read this in the local news and it was like, what is Geert Wilders doing in the middle of nowhere in Garland, Texas, giving a talk about Muhammad caricatures? That's not the obvious reason he actually traveled to Texas. What's going on right now is funded by people in the same area. So can we help a broader audience to actually sort of like show that there is this kind of influence going on? So we may not say, oh, this particular news item, this particular topic is emphasized or amplified by people who have a lot of money, even though for some topics we know, for, anti-transgender, it was $150 million in the last 6 weeks before the election. It's 700 million euros in the last 2 years in in Europe that is invested in these kind of issues. So obviously there's a very clear pressure of force. And the question is, can we reveal that generating mechanism? What kind of effect this has on the news and on elections in Europe?
Yeah, that's a great question. So I have a couple of things to say about this. So one thing is that in the other study on the event flows, so this was the ads and the articles, and in the other one I didn't show a graph here, but I've also looked at different newspapers with different ideological backgrounds. And one thing that I found is that there's one newspaper in the Netherlands that throughout the 20th century became more, well, let's say conservative, populist in a way. And their signatures and how they reported on events was completely different than all the other newspapers. Over time, it diverged. And in a way, it behaves much more like a tabloid in a way, a bit like some of the more extreme media, well, Twitter in a way, like constantly making news about stuff, like constantly like driving this attention economy. And this was one thing that we found using these metrics. And talking about the Hearst exponent, my colleague Christopher Nielbo has done some work on COVID reporting in Denmark. And he also found that the way that if something happened in relating to COVID, like I don't know, a lockdown, once they were announced again, or an evening, like a clock in the evening where you had to stay in, the way the time series responded to this also depended or differed very strongly between newspapers. So in that sense, yes, you can use these metrics to do this, and I think this taps into a larger point about that I think, well, okay, one thing with this sort of news cycle, this speeding up of the news cycle, is that we're also drawn into, oh, there's high entropy all the time because there's a new article or something new. But basically, if we zoom out, there's a lot of it is very stable in a way that it is changing. And the same is probably when we look at climate change, right? That if, oh, it's raining now, but tomorrow it's sunny again, oh, there's no climate change because, yeah, there's also warm days. But you only notice this when you look at the structure, basically, to get back to the talk, the larger structure. The same for turbulence, I think. The turbulence, there's like a lot of noise in that, but there's also a larger structure that explains how air flows and why that is turbulence. And I think one of the issues that I also find sometimes quite difficult in this is that you see a lot of graphs in news media, a lot of statistics that can be used in a very political sense, where it's basically, yeah, a model is what the model is doing. Of course, there's always politics involved. There's nothing is apolitical. But I think training people a bit more to abstract a bit more, looking at the bigger picture, looking at metrics that point to the bigger picture, I think would help in dealing with these issues as well. And I do see, without getting too deep into politics, that there is some pushback now in political realms on focusing on the larger issues, the longer term in dealing with structural things, rather than focusing on every crazy thing some authoritarian person in the world did every single day. Yeah. So, but yeah, so I think we could use these metrics and I to do this. And yeah, so I recommend this Christopher Nielbo paper on COVID that I think is called Decoupling the News or something like that.
Cool. Mike.
Yeah. Well, first I wanted to react a little bit to what you just discussed. I think actually this is this story Max described, there are several possible explanations. Exceeding amount of money sort of pumped into the system might be one of possible explanation. The change, for example, of the media landscape and sort of typical size of chunks of information that people consume may be a different one. And I would say that it is exactly probably the place where you can try to do natural experiments, because not in every country in the world it is the news are so controlled by big money as they are in the United States. I mean, the role of Murdoch in Britain notwithstanding, I think in sort of political advertisement, for example, the differences per capita like 2 orders of magnitude between Britain and the USA. So I mean, it should be possible to see if indeed putting more money is what is driving this. Yeah, and actually I wanted to ask a couple of concrete questions about firstly, well, probably let's concentrate on the first study. Basically, one question I had was obviously there is if I take a random day which sort of in your classification had no particular events, what will be the pattern? This pattern of Jensen-Shannon entropy you just how will it be just constant plus maybe some jump at 1 day or something like this? How it looks like when nothing happens?
Well, are there days where nothing happens? No, but
well, I mean,
no, but I see what you
as
mean.
far as I understood, you have sort of several dozens of events. So in your terms, nothing happens.
Yeah, I have to see, because I do recall that I took random events as well, like random dates, and looked what happened there and contrasted that with the dates that I selected to see if there is an actual difference between those dates and the randomly selected dates. But I cannot recall the details exactly how I proceeded in doing that. But it could well be that you take a random date and that a very clear pattern comes out, and that to me was an indication that okay, what happened? So for some of these dates, I actually looked at and that's where the close reading still comes in. That there was an event that. So I selected the 58 major events using Wikipedia, like a list of 20th century events in the Netherlands or worldwide, I mean. And there was an event that got a lot of coverage in the newspapers, but was not in any of these lists. So for some reason, people forgot about it, and that I found also interesting.
And can you show the slide where there are 4 types of patterns?
This one?
Yeah. So it seems to me that the pattern 3 should be more or less similar to what you expect in a random day. The middle one.
Yeah, I have to. Your faces are on top of that one, but that's yeah. You're absolutely right. The left is similar to the right. It's a little bit higher, I think, but that's you're right. Yes, that's sort of the standard the day.
Yeah, and the second question concerning this thing, I wanted to ask, basically, can you give some examples? So what you have this 5 patterns. Can you give examples of events of each type, and maybe some examples of the such forgotten events which you only identified from the data but not from Wikipedia?
Yeah, so the very boring answer is that they're in the paper, and I would have to look it up exactly what these were. But we try to explain why these things looked like they did, and of course here again it's sort of eyeballing. But we used we also described the clustering mechanism that we used to come to these 5 clusters. Because some of them look fairly similar. But for instance, one of the things with the second one is that the actual on the left side of the center point, the average is higher than on the right. So that is one of the distinctive things there. But yeah, the paper is online and there are some examples there.
Okay,
It's not the most satisfying answer. I'm sorry.
And forgotten event. Is there any systematic anything systematic you noticed in these forgotten events? For example, I would expect, I don't know, probably Netherlands are not as interested in their royal family as Britain, but I would actually expect that something like royal wedding in United Kingdom can be quite a significant event shown in the data, but looking 50 years afterwards, nobody will.
No, but then again, if you have these sort of events sometimes also have a cyclical pattern. So whenever someone is, I don't know, like the 10-year anniversary of something, and that is only, now we use only 28 days, but we also done some experiments on longer scales where you could actually see these dips for cyclical events. And related to the ceremonial things, you could find some of these. But yeah, so it also has to do with countries that are sort of. So one example that I do recall is a famine in I think, if I'm correct, what used to be Ethiopia, what is now Ethiopia. But there was a lot of Biafra. I think it was. I could be wrong if it's now Ethiopia, but I think that's so.
No, there was a famine in Ethiopia in the 70s.
Yeah. So, but now when we talk about famines, I think some other famines have sort of taken over in our public memory that one happened. But back then there were a lot of aid and discussions about aid and what do we do with this, and I think that is very typical for that period of time.
Nice.
And one more question I wanted to ask. Basically, very often you rely on topic modeling. For example, in the last part, basically you sort of
And this one as well, yeah.
You sort of said that we casually assuming that talks about inflation is a thing. The question, my question is basically how sensitive it is to modeling it in a different way, to splitting into other number of topics, etc., etc.
Yeah, that's a good question. I don't. So there's ways to establish the coherence of the topics. That is one way, but you can also do a robustness analysis where you basically vary the number of topics and keep the entire analysis pipeline the same. And we've done this for the epistemic captures paper. I mostly use topic modeling as a way to reduce the dimensionality of the text and not so much to look at the topics and say, this topic is about this topic is about that. For this particular paper, most of the analysis could be done without actually labeling the topics. So creating the network structure, we did label groups of topics basically just to add some explanatory power when we said there's different ways in which these communities behaved. Well, you could find this without actually looking at the text. But then if you want to tell a story about this, it does help if you could say, okay, but these are more about this. It helps in explaining it as well. But I do try to push back the actual reading of what the topic means until at a later stage. So for me, it's mostly a metric to go from a lot of text to something that I can work with.
Okay, thank you.
Super. I have one last question because we're reaching 2 hours, which is obviously a very simple question regarding your last slides, the architecture of information. So I love it that you use the word information there. You use the Anderson-Shannon divergence, entropy measures, stuff like that. So you really mean it. But this is relative to the discussion we had, like with historians not liking complexity, but saying it's complicated. A very similar issue, right? So like we here are in an environment where there's a lot of media studies going on, which, sort of like every one of those in the first semester reads Marshall McLuhan. who doesn't cite Shannon. So there's this like weird thing that information is something that it has a much more sort of like simple meaning, maybe, particularly when we talk news. Information is like what is new in the news, while you, just as well as we, for example, use information in the sense of information theory. And my question is like, is this something we should emphasize more and should sort of like evangelize more because it really makes sense? Would you agree?
I think one of the things that I really like about this information theoretic approach is that it gives you a principled way of trying to explain more than one single thing, basically. So not a metric that just works for this one single thing that you try to do, but the even when working with visual information, with textual information, with metadata, this theory helps in explaining, yeah, communication basically, or the way we process information. The uncertainty that's there, but also when I briefly mentioned this coarse graining, I often use the example of an MP3 when I talk about this and say, okay, you can have super high fidelity of like a vinyl record. I can turn it into an MP3 and reduce the bit rate, but you can still recognize the song, right? And then for me, that is a sort of an analogy of what I try to do with some of this historical data in that some of the structure still remains there. And that is sort of the information content there. So I find that a very elegant way of using this. And also the math is not, well, it works basically. That it's simple, but and other people have proven this. Simon DeDeo is of course one of the people that has worked extensively on this, that it's a valid thing. And the same goes for colleagues. I think you had Volkert Karsdorp and Mike Kestemont on as well when they talk about unseen species models. The math behind that also checks out. So it is not something, oh, you just chose this and randomly it works. Other people have shown that it's a system that works, and I think this is also one of these things. And I think there's others as well that we can use, but I think you're right that this resonates, I think, with people in the humanities, because you can use simple analogies to convey the thing you're talking about.
Yeah. So thank you very much. I need to do one last thing I do every week, which is announce what comes next week. Next week we got Andrew Piper from McGill University in Canada. He will talk about computationally modeling collective narratives. Has a nice swing to it. Melvin, this was amazing. Thank you very much. And I love to see you in person. So goodbye. This is sort of Open Lab seminar next week.
Sorry to interrupt you, but let's also mention that it will be not at 4, but at 5.
Okay. Yes, this is one thing we need to say. It will be at 5 p.m. because
it is too early, basically, in Canada.
Andrew needs some sleep. Exactly.